Hey, welcome back to chemistry. And now we're going to continue on with the chapter of stoichiometry of reactions. And so what I need to talk about now is sort of the difference between theoretical yield and actual yield and percent yield. So let me sort of introduce the concept with an example, and then I'll do some practice problems. So let me just kind of draw out an example on a board. Let's say you're following a chemical reaction. And so I have it there on the screen, but let me kind of write it on the glass board as well. So we're going to take propane, which is C3H8, and we're going to react it with oxygen, O2, and the products that we're going to get are carbon dioxide and water. Okay, so what you would probably have to do is balance the equation, so I'll do that really quickly. I'll just take the easy way out and just look at the numbers on the slide and just put them in there. Okay, so that should be a balanced equation. So one question we can sort of ask ourselves is this. So let's say we have 10 grams of oxygen, and maybe we're curious to see how many grams of CO2 or carbon dioxide you would get from that. So you can work it out, and so I've done that on the screen, but basically really quick, what you do is divide it by the molar mass of oxygen, and then you have to go from oxygen to carbon dioxide, so you need the mole ratio, so I'll pop that in. So it's 3 mole of CO2 over 5 mole of oxygen, and then what you have to do is multiply by the molar mass of carbon dioxide, and then if you do the math, what you'll find is if you start out with 10 grams of oxygen and you have an excess amount of propane here, in the end, your yield will be 8.25 grams of carbon dioxide. But here's the thing, this is a theoretical yield. This is a yield that we would expect doing the math from the equation that 10 grams of oxygen would provide. The problem is if you work like in a laboratory or you work in a chemical plant facility, you will never get the theoretical yield. You always get something less than that. And the reason is because the reaction usually happens inefficiently for various reasons. So you need to know the difference between the theoretical yield, which is basically the number you get by using the equation, versus the actual yield. The actual yield is probably something that you would not be able to calculate. It would have to be a value that would be given to you. So I think in this particular problem, the theoretical yield again is 8.25 grams of carbon dioxide. The actual yield is 5 grams of carbon dioxide. So this is theoretical. And then the problem tells you what the actual yield is. So the actual yield is 5 grams. Okay, so what you may have to figure out is, given the actual yield is a lot less than the theoretical yield, you may be curious as to what the percentage yield is. And so that's actually pretty easy to calculate. And so I show that here, that it's equal to the actual yield of 5 grams in this case, divided by 8.25 grams, the theoretical yield, and then times 100. And so we can see that the percent yield is going to be a simple calculation. I won't write it out, but basically again it's the actual yield divided by the theoretical yield times 100. And so it would be, in this case, 61%. So we have to sort of learn how to deal with problems where you might have to calculate a theoretical yield from the equation, compare it to an actual yield, and then work out the percent yield. So let's go ahead and do a problem that I have on the next slide. So get rid of this. So this is a really good example of a problem dealing with theoretical yields and actual yields. So the problem is calcium carbonate decomposes to form calcium oxide and carbon dioxide gas. And you're given the reaction there. And you're also given some molar masses. And then it says if 300 grams of calcium carbonate decompose, what is the theoretical yield of calcium oxide? And then what is the percentage yield produced if you only get 90 grams of product? Okay, so let's go ahead and sort of work out how we solve this problem. So we have calcium carbonate here, and it breaks down into calcium oxide, and you get carbon dioxide. So one thing I want to confirm is that this equation is balanced, and so we have one calcium on the left, one calcium on the right, one carbon on the left, one carbon on the right, 3 oxygens on the left, and then 3 on the right. So it looks like it's balanced. So it looks like we have 1 mole of calcium carbonate will break down to produce 1 mole of calcium oxide and 1 mole of carbon dioxide. So what we can do is first calculate the theoretical yield of calcium oxide if 300 grams of calcium carbonate decompose. So we have 300 grams here. So one thing you may be wondering, for example, is do you have to worry about limiting and excess reagents in this problem? And the answer is you don't, because we only have one reagent. And so I think if you have a problem with one reagent, you just assume that that one reagent just completely runs out. So what I'm going to do is take this 300 grams of calcium carbonate, and then what I'm going to do is figure out how many grams of calcium oxide I should get from that, and that will be the theoretical yield. And so this is sort of like what you've done before. So the first thing we have to do is we have to take grams of calcium carbonate and divide by the molar mass of calcium carbonate. So calcium carbonate divided by 100.09 grams of calcium carbonate. And so you see the grams of calcium carbonate cancel out, and so we get an answer in moles of calcium carbonate. And then we have to take this to calcium oxide. And so here we note the mole ratio in the equation. 1 mole of calcium carbonate gives you 1 mole of calcium oxide. So 1 mole of calcium oxide over 1 mole of calcium carbonate. Okay. So now at this point, we are at moles of calcium oxide. And so we have to convert that to grams of calcium oxide to figure out what the theoretical yield is. And so it's 56.07 grams of calcium oxide over 1 mole of calcium oxide. And so the moles calcium oxide cancel, and we get an answer in grams. So I think if you worked out the math, it's 300 times 1 times 1 times 56.07 divided by 100.09 divided by 1 divided by 1. And I think that should work out to be 168.0 grams of calcium oxide. So this is, again, a yield determined by an equation. So this is the theoretical yield. Theoretical yield. Now, what we have to next do is figure out the percent yield. And the only way you can do that is if the problem tells you what an actual yield is, because then you can divide that by the theoretical yield and multiply by 100 and get the percent yield. So percent yield is going to be the actual yield over theoretical yield times 100. So the actual yield, I think, is given. It's 90 grams. And you're dividing it by the theoretical yield, which is 168.0 grams, and then you multiply that by 100. And then the percent yield is 53.57%. And so that's how you solve that problem. So let's move on to a different problem. Next one. Okay, so with this next problem, let's see, we have when 6 moles of calcium reacts with an excess of V2O5, which is vanadium oxide, according to the balanced equation shown, 78.9 grams of vanadium, and there's a molar mass for vanadium there, are obtained. What is the percent yield of this reaction? Okay, so the first thing I want to do to solve this problem is I want to write an equation on the board. So we have V2O5, which is vanadium oxide, reacting with 5 moles of calcium yields 2 moles of vanadium plus 5 moles of calcium oxide. Okay, so let's see what information we have and then what are we trying to get here. So we are given a starting moles of calcium. So I'm writing here 6.00 mole of calcium. So the thing to note here is we're not starting out with a mass of calcium like we do with a lot of problems. We're starting out with moles of calcium. So that's just something to keep in mind. Now, we are told what the actual mass of the vanadium product we are going to get if we react 6 moles of calcium with excess
V2O5. And so let me just note there, with the vanadium product, this is what we actually get, is 78.9 grams of vanadium. But be careful, this is what you actually get. So this is an actual yield. So let me indicate that here. Now, in the end, you're not wanting to get like an actual yield or a theoretical yield. You want to get a percent yield. So let me talk about that. We're trying to find a percent yield. And so one of the things you might remember is that a percent yield is equal to an actual yield divided by a theoretical yield times 100. So we do know the actual yield. What we have to do from this problem is get the theoretical yield. And this is actually not so difficult to do. So let me show you how you go about doing that. So we know that we are reacting 6 moles of calcium with excess V2O5. Can you figure out what the theoretical yield of the vanadium would be if all 6 moles of calcium react with this vanadium oxide, V2O5? How would you figure that out? Again, not so difficult. So you know here that the mole ratio between calcium and vanadium is 5:2. So if you know the moles of calcium you have, you can figure out the moles of vanadium you should get. And then once you get the moles of vanadium, you can, using the molar mass of vanadium, which is given to you, get the grams of vanadium. And so that will be the theoretical yield. And so once you figure out the theoretical yield, you divide that into the actual yield and multiply by 100, and then that should give you the answer. So let's go ahead and work this out. So the first thing I want to do is I need to work out the theoretical yield of the vanadium from 6 moles of calcium that's reacting. So we have 6.00 moles of calcium. And again, what we're trying to do is we are trying to, in the end, get the grams of vanadium, which will be the theoretical yield. Okay, so you take the moles of calcium and you figure out, using the mole ratio of calcium to vanadium 5:2, what the moles vanadium would be. So I just write times 2 mole of vanadium over 5 mole of calcium. And you can see the moles calcium cancels out, and now we have an answer in moles of vanadium. Okay, now can you convert moles of vanadium to grams of vanadium? Sure, we know the molar mass of vanadium is given to us, so it's times 50.942 grams of vanadium over 1 mole of vanadium. And so the moles vanadium cancels here, and so we should get an answer in grams vanadium. And so again, this grams vanadium would be the theoretical yield that we should get if we have 6 moles of calcium. So I went ahead and did this earlier, and I found that the theoretical yield of vanadium is 122.2601 grams is what I got on my calculator. Now, can you figure out the percent yield of vanadium? So percent yield, as I told you before, is equal to the actual yield divided by the theoretical yield times 100. So the actual yield is 78.9 grams divided by the theoretical yield, which is 122.2601 grams, times 100. And I think if you work that out and correct for significant figures, the answer you should get is 64.5%. Okay, so let's move on to the next question.